Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
For part A, we're going to note that the normal force is equaling mg. And here, the maximum static frictional force, say lowercase f, is going to be equaling to the coefficient of static friction, mg. And so this would be equaling to 0.52 multiplied by 11 kilograms multiplied by 9.8 meters per second squared, and this is giving us 56 newtons. Therefore, in order to start moving, the horizontal force F must have a magnitude that is just a bit above 56 newtons. So, because 56 newtons is a minimum. So this would be your answer for part A. For part B, we know that we're going to apply Newton's second law in the y direction. So F sine of theta plus the normal force is going to be equaling to mg, or we can simply say that the maximum static frictional force will be equaling the coefficient of static friction multiplied by mg minus F sine of theta. And so we can say that now the horizontal component needed to initiate motion, we can say that for part B, F cosine of theta must be equaling to the coefficient of static friction times mg minus F sine of theta. So we can then solve for F. This would be equaling to the coefficient of static friction, mg, divided by cosine of theta plus the coefficient of static friction, sine of theta. And here we can say that F is going to be equaling to coefficient of static friction, 0.52, multiplied by 11 kilograms times 9.8 meters per second squared, divided by cosine of 60 degrees plus 0.52 times sine of 60 degrees. And this is giving us 59 newtons. This would be our final answer for part B. Now for part C, we're going to set theta equaling to negative 60 degrees. And so F is going to be equaling to 0.52 multiplied by 11 kilograms multiplied by 9.8 meters per second squared. And then this will be divided by cosine of negative 60 degrees plus 0.52 multiplied by sine of negative 60 degrees. And this is going to give us 1.1 times 10 to the third newtons. This would be our final answer for part C. That is the end of the solution. Thank you for watching.